Hello and welcome to Basic Electrical Circuits course. My name is Anirban and first of all tell me, how are you guys enjoying the course? Someone please tell me, is it too difficult or how is the course going? Okay, Dhanraj says fine. Others? Okay. Am I audible? Okay. So let's start the session. So before discussing any assignment problems, let's start with the most basic questions that can be in a basic electrical circuit. So I am starting with most fundamental 5 questions. Anybody can somebody is okay. So I am starting this session with 5 questions. So these are the most fundamental questions. Anybody can answer. So my first question is, what is a voltage or a potential difference? Anything that you feel, write it down in the comment, in the chat box. Dhanraj says the capacity of a charged body to work. But how do you quantify the amount of work? Anyone else? Exactly, from one point to another point. Anyone else who wants to try? Anyone? Potential energy, Mosam says potential energy per unit charge is called potential difference. Okay, here comes one more question. What do you mean by, what kind of potential energy are we talking about? Location, electric potential difference, also known as voltage, is the external work done in bringing a charge from one location to another location in an electric field. Lokesh, you are quite correct. Electric potential, just one correction you need, that is electric potential difference is the external work needed to bring a unit positive charge from one location to another location in an electric field. You should mention a unit positive charge, not just any charge. Good. Okay. So we have learned the first basic definition of basic electrical circuits, that is what is a voltage or a potential difference. So voltage or a potential difference is the external work done in bringing or in moving a unit positive charge from one point to another point in an electric field. No, potential at any point is not called a voltage. Voltage is the potential difference between 2 points. Whenever you say a voltage, you have to mention 2 points. If you say a point, that is the potential of that point. And in layman terms, sometimes in basic electrical circuit we casually say it's the voltage. So it is actually measured with respect to a reference point, that is ground node. So there are 2 points always involved when you define a voltage. Mosam, is that clear?
Yes, sir.
Okay. Good. So next question is, what is current? What is electrical current?
Flow of electron in per unit is current.
Abhishek, can you please repeat once more?
The flow of electron per unit is current.
I think you better write it down in the chat box. Your voice is not quite audible.
Rate of change of charge with respect to time is called current.
Yes, rate of change of charge. In better terms, you should say time rate of flow of charge is known as the current. Yeah, rate of flow of charge is not just electrons. Electrons in electrical engineering we consider electron, but in electronics we also consider holes, which are basically the opposite flow of electrons. But if we go to physics, so there people also move protons, so that flow is also can be considered as an current. So in electrical engineering we can say rate of flow of electrons, because we don't deal with protons and all. But yeah, rate of flow of charge is electric current. Oh, also you should mention in electric field, rate of flow of charge in electric field is the electric current. Okay. Any doubt? Anybody? Okay. So my next question will be, what is resistance, and from which law does the definition of resistance come from? Two questions basically.
Definition of resistance comes from Ohm's law, and resistance when the current flow in the wire, its oppose the current, the property is called resistance.
Yes. So in Ohm's law we say that the potential difference across a conductor is proportional to the current flowing through the conductor, right? Anyone? Just
No, sir. Current flow in the conductor directly proportional to the voltage across between the terminal.
yeah, that's what I said. Or I said something else. Actually you are correct. It's the current flowing through the conductor is proportional to the voltage across the conductor.
Yes, sir.
It's actually same, both ways it's same. You keep it, say voltage across the conductor is proportional to the current flowing through the conductor. It's the same. And that constant of proportionality is known as the resistance. V equals to IR.
Yes.
Okay? Everybody is getting it? You can ask if you don't get. Anybody, any problem? See, these are the basic definitions you should know before starting this course, because the whole course deals with potential difference, current, resistance, capacitance, inductance. So these are the basic concepts you must know before start going through this whole course. So any doubt you may have, you can ask. No doubt? Hello?
No, no, sir.
Okay. So my next question is, what is capacitance? What is a capacitance? Yeah, Mosam, you can say. Or anybody else wants to try?
Capacity to energy store.
Capacity for energy storage, that's quite vague, because inductor also stores energy. So how do you differentiate between?
In electrical form.
What do you mean by electrical form?
Electrical energy, sir. Charge के form में.
Exactly. That's what I wanted to hear. So charge. So when we speak about capacitor, what are the basic quantities that we need to know? Like in case of resistance, we mentioned two quantities, right? Can anybody say what are those quantities? When we define resistance using Ohm's law, what are the quantities that we considered?
Voltage and current.
Voltage and current. Good. So in capacitance, what are the two quantities that we consider?
Charge and voltage.
Good. Charge and voltage. Now it's the same as Ohm's law. Just define it.
Q directly proportional to V, Q equals to C.
Charge stored across the plates of the capacitor is directly proportional to the voltage across the capacitor, and the constant of proportionality is known as the capacitance of the capacitor.
Yes, sir.
Provided that the thing doesn't change with temperature, pressure and the other external conditions.
Yes.
Okay? Any doubt?
Yes.
Anybody else other than Mosam? Anybody has doubt? Okay, Lokesh has written capacitance is the ability of a component to collect and store energy in the form of an electrical charge. Yeah, you are correct, but I wanted to know the quantity capacitance. How is it defined? How do we mathematically define the capacitance? You are correct that capacitance is the ability, because not only in electrical circuits we define capacitance, we also define capacitance in hydraulics as well. So there we have in place of potential we have pressure difference, and in place of current flow we have flow of water. So there also we have capacitance, resistance and all this stuff. So in general, capacity is, you are correct, that ability of a component to collect and store energy, here in the form of electrical charge, and there it is in the form of the pressure levels. But in terms of the electrical circuit, how do you define capacitance? So it is the proportional constant that comes from the proportional relationship between the charge stored across the capacitor plate and the voltage across the, or the potential difference across the capacitor plates. Yeah, you are correct. Oh, C equals to Q by V it will be. Yeah, okay, good. Others, please also participate. Please don't stay quiet. Okay, so this brings us to the last
सर एक
yeah,
क्वेश्चन
okay, ask.
सर हिंदी में पूछो.
हाँ, हिंदी में पूछो.
सर बोले जो कैपेसिटेंस का वैल्यू एक्सटर्नल प्रेशर और टेम्परेचर पे भी डिपेंड करता है क्या?
हाँ, अगर मतलब जो कैपेसिटेंस का मतलब क्या है, दो प्लेट्स होते हैं ना, कंडक्टिंग
Yes.
दो प्लेट्स और बीच में एक डाइलेक्ट्रिक रहता है जो कि इंसुलेटेड होता है.
यस.
सही है. अब वो
Yes.
इंसुलेटर को जो डाइलेक्ट्रिक का जो डाइलेक्ट्रिक कांस्टेंट है वो मतलब कभी कभी एक्सटर्नल कंडीशंस लाइक टेम्परेचर, प्रेशर, इनमें डिपेंडेंट होता भी है और नहीं भी होता है.
यस.
तो हम हमारे अगर कैपेसिटेंस को एकदम ही प्रॉपर्ली डिफाइन करना है तो हमें इन एक्सटर्नल कंडीशंस को कंसिडर नहीं करना है. एक्सटर्नल कंडीशंस कांस्टेंट मानना है कि वो सेम है.
ओके.
और हम लोग जब बाद में जाके हम लोग सब सर्किट डिज़ाइन करते हैं तो वहाँ पे जो कैपेसिटर हमें जो रियल लाइफ कैपेसिटर मिलता है वहाँ पे मेंशन किया रहता है कि ये है इस टेम्परेचर में ये टेस्टेड है, इस टेम्परेचर में इसका इतना वैल्यू टेस्टेड है. तो वो हमेशा एक टेम्परेचर और एटमॉस्फेरिक प्रेशर के रिस्पेक्ट में ही बोला जाता है, एक्सटर्नल कंडीशंस के रिस्पेक्ट में ही उनको डिफाइन किया जाता है. रियल कैपेसिटर्स का बात कर रहा हूँ जो हम लोग यूज़ करते हैं सर्किट्स में.
फैन में जो कैपेसिटर लगा होता है सर, तो उसमें भी कुछ टेम्परेचर प्रेशर कंसिडर किया गया होगा.
किसमें बताओ?
फैन में पंखा.
हाँ, पंखे में जो कैपेसिटर वो तो हमारे हमारे जो टेम्परेचर है नॉर्मल जो एटमॉस्फेरिक प्रेशर, तो वो प्रेशर ऑलमोस्ट सेम ही रहता है और टेम्परेचर जो रहता है हम लोग का उसके हिसाब से ही डिज़ाइन रहता है जो है कितना 30 से 35 डिग्री टेम्परेचर.
रूम टेम्परेचर.
हाँ, रूम टेम्परेचर जो है हमारा उसमें ही डिज़ाइन रहता है.
ओके सर, थैंक यू.
ठीक है, चलो अगला क्वेश्चन में जाते हैं. नेक्स्ट क्वेश्चन इज व्हाट इज इंडक्टेंस.
कैपेसिटी टू एनर्जी स्टोर इन मैग्नेटिक फॉर्म.
हाँ,
इन मैग्नेटिक फील्ड.
हाँ, वही एबिलिटी, वही जो लोकेश ने जो डेफिनेशन दिया उसके आसपास, बट मैं कह रहा हूँ कि मैथमेटिकल फॉर्म में बताओ.
हाफ एल आई स्क्वायर.
हाँ, हाफ एल आई स्क्वायर तो ठीक है. मैं कह रहा हूँ कि इन टर्म्स ऑफ बेसिक इलेक्ट्रिकल सर्किट्स के रेस्पेक्ट में बताओ कि हाँ दो क्वांटिटीज क्या है इंडक्टेंस में, जैसे कि रेजिस्टर्स का वोल्टेज और
V इक्वल टू L डी बाई डी टी. सर
नहीं, सोचो सब सोचो, वो नहीं है. ऐसा ही एक प्रोपोर्शनल रिलेशन होगा. जैसे हम रेजिस्टेंस में कह रहे थे कि वी कंसिडर दैट द वोल्टेज अक्रॉस द कंडक्टर इज प्रोपोर्शनल टू द करंट फ्लोइंग थ्रू द कंडक्टर. इन केस ऑफ कैपेसिटर वी सेड द चार्ज stored is proportional to the voltage across the capacitor plates. Here also we have similar definition, proportional definition. Anybody else wants to try? Anybody? Sai Shiva says flux proportional to current. You are close, but it's not flux. Remember your 12 course, physics course. It's not flux. No, Amarnath, no. It will be a proportional relationship. Sai Shiva is partially correct, but it's not flux, it's flux something. Flux something proportional to current.
L equals to sir n square mu a by L.
You are absolutely correct, Mosam. Now think, just remove the current and okay. L into I is what? L multiplied by the current. Inductance of coil multiplied the current flowing through the coil is what? Yeah, Lokesh, I am trying to explain. Amarnath says L equals to not flux. The same mistake you are doing. It's something, flux something by current. It's not flux. Anybody wants to try? Anybody else? Yeah, magnetic flux something. Magnetic flux something. You have read it in class 12 also. No. Okay. So, well, inductance is defined as follows. So, the magnetic flux that links through the coil, not any magnetic flux. So it's known as the magnetic flux linkage. Yeah. So it's basically okay, I'm repeating. So you have a coil. So you have a coil and current is flowing through that coil. Now that current will produce some magnetic flux. That's true. Now the amount of magnetic flux that links the coil, that is flowing through that coil, is known as the magnetic flux linkage. And magnetic flux linkage is defined as magnetic flux into the number of turns in the coil. So what is the definition of inductance? So the current flowing through a coil is proportional to the magnetic flux linking the coil, and the constant of proportionality is known as inductance L. So we say magnetic flux linkage, we represent it as psi, so psi equals to L into I. So is it clear, Lokesh? Others?
Yes, sir.
Okay, so we are done with these 5 definitions, basic definitions. Now I am proceeding with the assignment problems. So did you find the assignment problems to be difficult, or was it okay, or hello? Anyone can say.
Yes, sir.
Was it difficult?
Average.
Average. Okay. So let's see what were the problems. Is my screen visible?
Yes, sir.
Okay. So this was the first question. So an AC voltage of 230 volt RMS and 50 Hertz is supplying a load that comprises of a 10 ohm resistor and a 5 millihenry inductor. Now calculate the RMS value of the current through the load and the power factor of the load. So any doubt in this question? So we have to calculate the RMS value of current. So I is equals to V by R plus J omega L. So we can calculate the magnitude of I, which is the RMS. So it's 22.72 amperes. And to calculate the phase difference, we have to take tan inverse of omega L by R, and we get cos phi equals 0.987, which is lagging. So any question regarding this question number 1? Any doubt? Anyone?
No, sir.
No doubt. Okay. Yeah. Any doubt?
No, sir.
Okay. Question 2. So how much charge is represented by 2000 electrons? So what's the charge of an I've written it. So what's the charge of an electron?
Minus 1.6 into 10 power minus 19.
Coulomb. Yeah.
Yes.
So into 2000 it becomes minus 3.204 into 10 to the minus 16 coulomb, right?
Yes, sir.
Okay, so it's also easy. Next question. Kirchhoff's voltage law and Kirchhoff's current law are derived from which basic laws of physics respectively? So it's Kirchhoff's voltage law has been derived from conservation of energy, and Kirchhoff's current law is derived from conservation of charge. Any doubt in this one? How it has come up?
No, sir.
Okay. Next question. Two generators are supplying active power of 20 watt at 0.8 power factor lagging and 16 watt at 0.9 power factor lagging respectively to a load Z. The current through the load is 6 ampere RMS. Calculate the voltage across the load and the power factor of the load. So to calculate the total power flow, so 20 watt is the active power. So to calculate the magnitude of the apparent power, we need to divide 20 by 0.8 because the magnitude of apparent power into the power factor gives you the active power. So we need to first calculate the magnitude of the apparent power, and it will be with an angle of cos inverse 0.8 because it's 0.8 power factor lagging. And the next is 16 watt at 0.9 power factor lagging. Similarly, it will be 16 by 0.9, giving you the magnitude of the apparent power with an angle of cos inverse 0.9. So you get the total power flow to be, total apparent power flow to be 42.585 with an angle of 32.3 degrees. So the apparent power is equals to V into I. So you divide the current, so you get the voltage. Now, so as you get the voltage, it's 7.097 volts and it's 32.3 degrees. Okay, so it's plus 32.3 degrees. So what should be the power factor, leading or lagging? And why? Hello? Anyone? Hello? Am I audible?
Yes, sir.
So just say that why is it, what should it be, lagging or leading? 32.3 degrees positive, 32.3 degrees. The voltage is leading the current. So what should be the power factor, leading or lagging? Or you can say anything, no issue.
Lag, sir.
Why?
सर cos phi इक्वल टू R by Z. अगर वोल्टेज लीड कर रहा है तो इम्पीडेंस लैग करेगा.
वोल्टेज अगर लीड कर रहा है तो
उसके अप्रॉक्स में B इक्वल टू तो I इक्वल टू,
हाँ,
I इक्वल टू V by Z होता है ना सर.
I इक्वल्स टू V by Z होता है, एकदम सही.
यस सर. अगर वोल्टेज अगर लैग कर रहा है तो उसके, अगर करंट अगर मान लेते हैं लीड कर रहा है तो इसके रिस्पेक्ट में इम्पीडेंस तो लैग करना चाहिए. तो उसके अनुसार cos phi R by Z.
हाँ, सही है, बट वैसे नहीं सोचते हैं. एक्चुअली ये जो पावर फैक्टर का एनीथिंग दैट लैगिंग और लीडिंग पावर फैक्टर दैट वी से, it is actually of the current with respect to voltage.
Yes, sir.
Right. So if you consider impedance, it will be the negative of that, because it's I equals to V by Z. So तुम जो कह रहे हो कि वोल्टेज प्लस 32.3 डिग्रीज है, तो करंट इज 0 है, तो इम्पीडेंस भी प्लस 32.3 डिग्री होना चाहिए. उसका हिसाब से तो वो लीडिंग हो गया. वैसे नहीं होता है. इट्स ऑलवेज यू नीड टू चेक व्हाट इज द हाउ इज द करंट वेव फॉर्म विथ रेस्पेक्ट टू द वोल्टेज वेव फॉर्म. सो इफ द करंट वेव फॉर्म इज लैगिंग, इट्स लैग. So power factor is defined with respect to the current waveform.
Yes, sir.
How the current waveform is with respect to voltage. So if current is lagging the voltage, it will be lag. If current is leading the voltage, it will be lead. Okay. So remember this. Power factor is always defined with respect to current.
Yes, sir.
Okay. Any doubt? Anybody? If you are writing in the chat box, I can't see because I am just now sharing the screen, so you have to ask if you have any doubt. Any doubt? Any doubt? Anybody?
No, sir.
Okay. So let's move to the next question. four loads are connected in parallel. Their impedances are 1 minus J1 ohms, 1 plus J2 ohms, J5 ohms and 1 plus J3 ohms respectively. So they are connected in parallel. So so one very interesting question. We all know that Z is what is Z known as? What do we call Z? Impedance. 1 by Z is known as admittance. Good. So when the four loads are connected in parallel, what happens?
इंडिविजुअल का एडमिटेंस निकाल के उसको सम कर देंगे.
एकदम सही. इंडिविजुअल का एडमिटेंस निकाल के उसको सम कर देंगे. We add up all the admittances of the loads and we will get the admittance of the equivalent load. One upon that and then we will get the impedance. So वैसा ही किया गया है और C is the answer. Okay? Any doubt? Anyone?
No sir.
Okay. Let's move to the next question then. अच्छा. This is basically you need to solve this circuit and get the values of V1 and V0 and V2, right? V0 and V2. So this is you need to just do the calculations. If you have any doubt, you may ask, because this is pure calculation. Nothing to point upon this. Any doubt? Anybody in this question?
No sir.
No doubt, right? Okay. So this is very straightforward. Current through 5 millihenry inductor is given by 3 into T, where T is in milliseconds. So it's from 0 to 2 milliseconds, it's 3T ampere. It's 0 ampere from 2 milliseconds to 4 milliseconds, and from 4 milliseconds to 6 milliseconds it's 20 minus 3T. Now you need to find the voltage across the inductor at T equals to 2 milliseconds, T equals to 4 milliseconds, T equals to 6 milliseconds. So as you all know, V equals to L di by dt. Okay, so as can anybody recall at the beginning of the session we discussed what is the definition of the inductance in terms of electrical circuits? Anybody? Please say it out loud. हेलो.
यस सर.
हाँ बोलो, क्या वो जो डेफिनेशन दिया था इंडक्टेंस का?
सर, इंडक्टेंस इज ए मैग्नेटिक सर्किट व्हिच स्टोर एनर्जी इन मैग्नेटिक फॉर्म.
हाँ, बट वो फ्लक्स लिंकेज का जो डेफिनेशन बोला था,
n स्क्वायर म्यू ए बाय एल.
हाँ,
फाई इक्वल टू एल आई सर.
Phi is equals to Li. Phi क्या होता है? What is
phi? Is leakage flux.
It's not leakage flux.
Linkage flux.
It's we do not say it linkage flux. It's a wrong choice of words. It's flux. It's magnetic flux linkage. Magnetic flux linkage, not linkage flux. Magnetic flux linkage. याद कर लो. Magnetic flux linkage.
Magnetic flux linkage.
Yeah. So now who can say so yeah, phi equals to Li. Now who can say Faraday's law? Anybody? Faraday's law? Faraday's law क्या होता है?
किसी भी सेट ऑफ कंडक्टर को यूनिफॉर्म मैग्नेटिक फील्ड में अगर मूव कराते हैं तो उसमें फ्लक्स जनरेट होता है. फ्लक्स की वजह से ईएमएफ इंड्यूस होता है. हाँ. और लेंज लॉ की वजह से ईएमएफ जो होता है वो
को
अपोज करता है सर,
एकदम
E इक्वल टू माइनस एन
so
डी
the
फाई बाई डी
voltage
टी.
generated across is opposes the flux linking that coil, and it is proportional to the rate of change of the flux linkage, right? Or rate of
Yes,
change
sir.
of flux. Yes?
यस सर.
किसी को डाउट है? तो Lokesh, you were saying ना कि V equals to L di by dt, or somebody else was saying that the inductance is V by di by dt, right? When I was saying that what is inductance, so that definition is actually wrong. So it actually is derived from the basic definition that inductance is the constant of proportionality in between the flux linkage of the coil, magnetic flux linkage of the coil, and the current through the coil, and the Faraday's law. The Faraday's law states that it is proportional to the rate of change of flux linkage. So if you consider V equals to d psi by dt, or minus d psi by dt if you consider Lenz's law. So d psi by dt and psi is L into I. So if you combine these two, we get Vt equals to L di by dt. Okay. Is it clear?
Yes.
Okay. So you do the computation and you will get it to be 15 volts, 0 volts and minus 15 volts. So these numbers are nothing, but you need to understand the basic concept behind it. Okay. These concepts are very small concepts, but this needs to be clarified at the earliest, क्योंकि पूरा course जो है it will be dependent on these concepts only. Okay, let's move to the next question. Okay. So we have a DC network. We do not know what's inside it. It's a black box, and we have a resistance connected to a port that is taken out. So when the resistance is 10 ohms, the voltage across it is 20 volts. When the resistance is 20 ohms, the voltage across it is 30 volts. How to find out VR when the resistance is 80 ohms? So how to do this problem?
लीनियर प्रॉपर्टी से कर देंगे सर.
हाँ, लीनियर प्रॉपर्टी से कैसे करोगे? पहला बात, ये डीसी नेटवर्क है, तो वी नो फॉर श्योर दैट देयर इज नो इंडक्टेंस और कैपेसिटेंस इन्वॉल्व, एवरीथिंग इज रेजिस्टेंस, राइट?
यस सर.
इसमें कोई डाउट नहीं है किसी को भी? किसी को डाउट हो तो पूछ लो. मैं चैट बॉक्स नहीं देख पा रहा हूँ, सो प्लीज आस्क. कोई डाउट है किसी को? Anybody is having doubt? Please ask. Okay, so yeah, what was I was discussing. So हाँ, linear property से कैसे करेंगे उसको बताओ. सही बोल रहे हो? हेलो.
यस सर.
ऑडिबल हूँ?
यस सर, ऑडिबल.
हाँ, बताओ how you can go about it. लीनियर प्रॉपर्टी से सही बता रहे हो?
एक सर रिलेशन निकाल लेंगे दो गिवन पॉइंट जो है VR जो दिया है दो बार.
हाँ, VR जो दिया हुआ है. हाँ, ये एक चीज बताओ प्लीज, एवरीबॉडी ट्राई टू गेट दिस. सो व्हेन R is 10 ohms, R is 10 ohms, there is some voltage, and R is 20 ohms, there is 30 volts. So different voltages. So यहाँ से हम क्या conclude कर सकते हैं? What can we conclude from this two observations? That the voltage is
Sir, display this 8th question, sir. 8th question, kindly display the 8th question. It is showing 7th.
yeah, I am keeping it to 7 because in the 8th question the solution is given. I don't want to show you the solution before discussing.
Yes sir.
तो solution देखने में प्रॉब्लम नहीं है. Okay. So हाँ, तो what the thing that I was saying कि yeah. So what is the basic observation? When here it is written that two data points are given, r equals to 10, Vr is 20, r equals to 20, Vr equals to 30. Very easy. Just think about it. What is the very basic observation that we see from here? कुछ भी, जो भी मन में आए बता दो.
सर आर डबल होने पे वी आर सर 1.5 टाइम्स बढ़ता है.
1.5 टाइम होता है, वो भी देखने का जरूरत नहीं है. द बेसिक थिंग इज द वोल्टेज इज चेंजिंग, राइट?
Yes sir.
The voltage changing means the DC network is not a voltage source. This we can conclude for sure.
Yes sir.
It's not an ideal voltage source.
No.
Right?
Yes.
So if it's not an ideal voltage source and okay, now it's a DC network. So the other component that can come is the resistance.
Yes sir.
Okay. Now what is, so we need to model this DC network in terms of a voltage source and a resistance, that we know for sure. Yeah.
नो सर एक बार और.
हाँ,
एक बार फिर से सर समझे.
हाँ, तो ये जो DC नेटवर्क है, this we can represent in terms of a voltage source and a resistance. Whatever combination, we don't know the combination. We can represent it in terms of a voltage source and a resistance, because voltage change हो रहा है. इसका मतलब voltage source जो है ideal नहीं है, तो वो voltage source में कुछ resistance है. ये हम conclude कर सकते हैं.
Yes sir.
कोई किसी को कोई डाउट है? Anybody has any doubt? No. Okay, so okay. Now please tell, how will the resistance come across? Will it be parallel to the voltage source or series to the voltage source?
Series to the voltage sir.
Why not parallel?
करंट रेजिस्टेंस तो करंट सोर्स के पैरेलल होता है ना, वोल्टेज सोर्स पे सीरीज हो जाता है.
हाँ हाँ, यू आर एब्सोल्युटली करेक्ट, बट क्यों नहीं होता है? लॉजिकली उसको बोलो. वोल्टेज सोर्स के पैरेलल होगा तो क्या होगा? अभी एक पॉइंट डिस्कस किया कि याद करो, इट्स ऑल्सो रिटेन इन दिस सॉल्यूशन.
So the equation says that voltage is equal to sum of resistances. What is 20 by 10 into R plus 20 is again a resistance, sir.
Yeah. Please repeat, please.
Sir, voltage is equal to,
Yeah.
sir, voltage is equal to 20 by 10 R plus 20 here. This
Yeah.
ratio into R plus 20 provides you the idea about the resistance value. How can an equation be equal to voltage is equal to resistance here?
Where do you find 20 by 10? It's the current, right? VR by R. It's the current flowing through this resistance.
Actually 20 is the voltage, sir. Is that correct? 20 is the voltage and 10 will be?
Resistance.
Okay.
And R is the unknown resistance that is in series with that voltage. We are coming to it, but why is the resistance in series and not in parallel? Is my basic question first.
Yeah, parallel in the sense voltage will be same, no?
Exactly, the voltage will be same. So at the first we have said that we cannot have an ideal voltage source, that we can see that voltage changing. So the only possible combination is the voltage source and the resistance series to it. You are absolutely correct. So we can represent this DC network as a voltage source and the resistance R in series with it. Okay, now we can write the equations. So the voltage V, now you can apply KVL. So V equals to how much? V equals to this VR is 20. It's 20 plus the current flowing is VR by R, so it's 20 by 10, it's 2 into that small r, the unknown series resistance. So it's 20 by 10 R plus 20, and the second equation will be V equals to 30 by 20 into R plus 30. So solving these two equations, we get V equals to 60 volt and the small r equals to 20 ohms. And from here, if we have a load resistance of 80 ohms, we can calculate this calculation we can do to be 48 volts. Any doubt?
No sir, it's clear.
It's basically V equals to IR plus this VR, the current into resistance through the series resistance plus the VR. Okay, it's not this part is totally not resistance, it's voltage equals voltage only. KVL is being done, basic KVL.
The small r is provided as a capital R in the diagram, sir. Is that correct?
No. Small capital R is the load resistance. The small r is the series resistance that we are modeling this.
Which is there in the network. You are saying that resistance which is there in the network.
Yeah, this DC network. This part is the DC network. Yeah. This R is connected outside. From outside it is connected. Inside this series resistance is there. Voltage in series with a resistance. Okay, let me draw. I think that will be better. So what I am saying is, so you have a voltage source and you have a resistance here. This is R, small r, and this is the capital R. So this part is my this is my DC network. Okay, this square part, you got it? This part is, this is my DC network. This DC network.
Yeah, sir. Clear, sir. Thank you.
Okay. So shall we proceed to the next questions? Any more doubts?
No, sir.
Okay. Another circuits question. So we need to find out the voltage across these 4 ohms from in this circuit. So basically you need to apply KVL and KCL again. So you have 2 loops. So this is loop 1, loop 2. So we have the KVL equation in this loop as this is the KVL equation for this loop, and then for this loop we have this KVL equation, and for this node A point we have this KCL equation, and for B point we have this second KCL equation. Now solving these equations we get I3, this is the current I3 to be 0.25 ampere, and 0.25 ampere into 4 ohms, it's the 1 volt. So this is quite straightforward calculation type question. So any doubt if you have, please ask.
No, sir.
Okay, the last question. So in an experiment, a capacitor with capacitance value of 2 microfarad rated for 100 volt is needed. So to do the experiment, how many 1.5 microfarad 800 volt capacitors are needed? So yeah, Acha, please don't see the solution. Please tell me how to do it. Okay, actually there is a mistake in this question. this will be 2 microfarad rated for 800 volt is needed, and how many 1.5 microfarad of 100 volt capacitors are needed. So there is a mistake in this question, right? Now tell me how to do it. Anybody? How to do it? Yeah, please go ahead. You have 1 point. I forgot it again. Yeah, you have 1.5 microfarad 100 volt capacitors. You have 1.5 microfarad 100 volt capacitors, and you need 2 microfarad 800 volt capacitor. How can you achieve it? Anybody? Anybody wants to try? Anybody? Mosam, you want to try?
सर हमको क्वेश्चन समझ में नहीं आया, फिर से एक बार हम।
हाँ, तो तुम्हारे पास 1.5 माइक्रोफैराड का और 100 वोल्ट रेटिंग का कैपेसिटर है, ठीक है?
यस सर।
और तुम्हें चाहिए एक कैपेसिटेंस जो है 2 माइक्रोफैराड का, और तुम्हें 800 वोल्ट होल्ड करना है उस कैपेसिटर से।
यस सर।
तो तुम्हें इन 1.5
So the question itself, the rated voltage will be 800 volts, sir, 2 microfarad.
Question is incorrect.
The
question is wrong. It will be
the question 800 volt for 2 microfarad rated.
Just a second. I think the question is I think it's actually changed. Basically you need the question should be, in an experiment a capacitor with capacitance value of 1.5 microfarad rated for 800 volt is needed. So to do the experiment, how many 2 microfarad 100 volt capacitors are needed to obtain this value? This should be the question, right? Please check and tell me if I am right or not.
Sir, 1.5 microfarad 100 volt is needed, right?
1.5 microfarad 100 volt is provided to you, the capacitor, n number of capacitors of that rating.
Yes sir.
And you need to ensure a 2 microfarad 800 volt capacitance, equivalent capacitance, a pack using these capacitors.
तो सर अगर वोल्टेज ज्यादा चाहिए तो हमको तो सीरीज में ही लगाना पड़ेगा।
सीरीज में लगाना होगा, एकदम सही। तो सीरीज में लगाएंगे तो क्या होता है कैपेसिटेंस का?
कैपेसिटेंस को 1/C इक्विवेलेंट इज इक्वल टू 1/C1 प्लस 1/C2 प्लस 1/C3।
एकदम सही। तो वो 100 वोल्ट का कैपेसिटर है हर एक, तो 800 volt reach करने के लिए how many capacitors should be in series?
8.
8. Good. So what will be the series capacitance total equivalent? C by 8.
Yes sir, C by 8.
So 2 by 8.
C by 8. Yes sir.
2 microfarad है.
Yes sir, 2 microfarad. 2 by 8.
2 by 8 हो गया, 0.25 microfarad हो गया.
Yes sir.
तो हमें अब 0.25 माइक्रोफैराड अचीव कर लिया, 800 वोल्ट अचीव कर लिया. अब हमें 1.5 माइक्रोफैराड अचीव करना है. तो ये तो इट्स इंक्रीजिंग. सो क्या करना है? व्हाट काइंड ऑफ कॉम्बिनेशन शुड वी मेक ऑफ दिस पैक? पैरेलली. तो ऐसा कितना पैरेलल चाहिए? 6. 0.25 into 6 is 1.5.
Yes sir.
So how many capacitors are needed? 6 into 8. 8 सीरीज में, वैसे 6. तो 6 into 8 48 capacitors.
Yes sir.
सही है?
Yes sir.
Okay, good. बाकी किसी को डाउट है? The question is.
Yeah, I have a doubt, sir.
Yeah,
sir. Sir, for the same calculations, if you go for two combination, that is 0.25, one bank is there, 0.25 you will get a 0.5 there. If you have it in parallel. If you have 1.5 provided 1.5 microfarad capacitor which is of 100 volt and two capacitor banks of this, okay, you will get a 2 microfarad there.
Provided is 2 microfarad, 100.
Oh, you are providing only 2 microfarads, no?
We are providing, the question is wrong actually. We are, just a second.
We have to form 1.5, is that 2 microfarad capacitance with 800 volt or 1.5 microfarad capacitance with 100 volt?
Clarifying it. Just a second. Just a second. I am facing a bit. यहाँ पे it will be better. So given. Sorry. Given is 2 microfarad 100 volt caps. Okay, this you can have n number of, and what we need to achieve, we need to achieve 1.5 microfarad 800 volts. This we need to achieve. Sorry, should be point. This we need to achieve.
Now it is clear, sir. Now it is clear.
Okay. Actually, the question is wrong. I told. Okay. The question is wrong. Actually, it should be the other way around. Okay. Actually, here it has been needed 2 microfarad 100 volt. It's not. This should come here and this should come there. So yeah, the question is wrong. Okay. So that brings us to the end of the assignment questions.
सर तो ये लास्ट वाले क्वेश्चन को तो चेंज करना पड़ेगा असाइनमेंट में.
हाँ, ये तो चेंज करना होगा. तो इसको एक करेक्शन के तौर पे मैं आई विल सेंड इट. ओके.
यस.
ओके. सो जस्ट अ सेकेंड. Is anybody here is from the NPTEL has joined?
सर असाइनमेंट कैसे सबमिट करें?
हाँ,
असाइनमेंट कब सबमिट करें?
Abhishek, your voice is not at all clear. Can you just write in the comments in the chat box? Just a second. Okay, I will talk regarding this. This question is actually wrong. So it can be done about it. It should be the other way around, right? So okay, I will talk to the concerned people regarding this. Okay, hello.
Okay, sir.
Okay, so that brings us to the end of the assignments, and those basic 5 definitions I will it will be there with the presentation notes. It will be there attached, the basic 5 definitions of potential difference, current, capacitance, inductance and resistance. So you can access it later also. And yeah, so any more doubt other than the assignment and these stuffs with regarding course, if you have, you can ask. And
असाइनमेंट सबमिट कैसे करेंगे?
असाइनमेंट सबमिट नहीं करना है. असाइनमेंट तो वो you need to go to the NPTEL that course platform, and there is the assignment. You need to do it right there, और उसके बाद वहाँ पे ही सबमिट होता है. यहाँ पे मतलब there is nothing you need to upload or anything. Like एक second. So suppose this is the course. So यहाँ से नहीं दिखाई देगा. You need to log in. अच्छा, you need to log in for that. Okay.
सर असाइनमेंट पे जाने पर ना लास्ट में सबमिट का एक आता है, सबमिट करने
हाँ,
का.
सबमिट का कुछ ऑप्शन आता है, मुझे भी पता है, बट इसके लिए अभी लॉग इन करना होगा. अदर देन दैट अभी तो नहीं दिखा सकता. बट हियर आफ्टर द लेक्चर देयर विल बी एन असाइनमेंट. यू नीड टू डू इट राइट हियर एंड देन सबमिट इट. ठीक है. ठीक है, तो और कोई क्वेश्चंस है regarding the course? ठीक है, तो किसी को भी और कोई क्वेश्चन है? नहीं तो आई विल एंड दिस सेशन.
हेलो हेलो.
हाँ हाँ हाँ.
सर ये मैं पूछना चाह रहा था कि अगर कोर्स में जैसे कुछ डाउट्स आता है तो क्या आपको डिस्कशन पोर्टल पे फ्रेम कर दें तो वहाँ से आंसर मिल जाएगा?
हाँ हाँ, डिस्कशन पोर्टल में भी शेयर करके आंसर मिल जाएगा. बिकॉज योर फेलो फ्रेंड्स विल ओनली हेल्प यू, एंड इफ दे डोंट हेल्प वी आर देयर टू हेल्प यू. और हमेशा तो डिस्कशन पोर्टल हम चेक नहीं कर पाते हैं, सो इट्स बेटर यहाँ पे ही पूछ लो.
नहीं सर, अभी तो क्या वीक 1 और वीक 2 में ऐसा कोई डाउट नहीं है. जैसे
हाँ हाँ हाँ, अगर डिस्कशन पोर्टल में डिस्कस करना है तो कोई दिक्कत नहीं है. बट यहाँ पे पूछ लोगे. हाँ, ये डिस्कशन, ये जो सेशंस है ये हर हफ्ते ही होगा. सो
जैसे अगर किसी हफ्ते में डाउट है तो यहाँ भी मैं आस्क कर सकता हूँ, आपसे पूछ सकता हूँ ना?
हाँ हाँ हाँ, एकदम.
ओके सर, थैंक यू.
विदाउट एनी हेजिटेशन. कोई हेजिटेशन मत करो कि ये समझ में नहीं, क्या सोचेगा बाकी लोग.
हाँ नहीं नहीं सर, वो बात नहीं.
हाँ हाँ, ठीक है. और कोई क्वेश्चंस? वो जो पहले जो डेफिनेशंस डिस्कस किया था उनमें कोई डाउट्स है किसी को तो पूछ सकते हो. कोर्स रिलेटेड कुछ पूछ सकते हो.
यहाँ पे NPTEL पे 2 कोर्स आते हैं, एक बेसिक इलेक्ट्रिक सर्किट, एक इलेक्ट्रिकल सर्किट.
अच्छा, ऐसा भी है. देखने दो मुझे. इलेक्ट्रिकल सर्किट. हाँ, बेसिक इलेक्ट्रिकल सर्किट है.
तो इस दोनों में डिफरेंस क्या है सर, जो दोनों को अलग अलग किया गया है?
मुझे भी नहीं पता, मैं भी देख रहा हूँ पहली बार। एक सेकेंड, ये सेम कोर्स है।
नहीं सर, एग्जाम डेट दोनों का अलग अलग है।
हाँ एग्जाम डेट अलग है, बट मतलब कोर्स का कंटेंट तो सेम ही दिख रहा है।
कुछ सर कंटेंट उसमें अलग है, इसमें नहीं है। उसमें 2 पोर्ट है, इसमें 2 पोर्ट मतलब नहीं। इसके प्रोसेसर भी अलग है।
2 पोर्ट है इसमें भी?
इसमें नहीं है सर शायद।
हाँ है दिखाता
है
हूँ।
सर। जैसे सर ओपैम्प है इसमें, उसमें नहीं है ओपैम्प।
हाँ आई थिंक वो जो है तुम्हारे एनालॉग मतलब इलेक्ट्रॉनिक्स के तरफ थोड़ा फोकस्ड है, इलेक्ट्रॉनिक सर्किट्स एंड ऑल। यहाँ पे सिर्फ इलेक्ट्रिकल मतलब जो पावर ट्रांसफर के लिए जितना हमको ज़रूरत होता है उसमें ज़्यादा फोकस किया गया है। वहाँ पे एनालॉग सर्किट्स में भी इक्वली वेटेज दिया गया है। बट यहाँ पे भी 2 पोर्ट नेटवर्क है, ये देखो 2 पोर्ट नेटवर्क सब कुछ है। बट ऑपएम्प्स नहीं है, ऑपएम्प्स नहीं है वो बोल सकते हो।
यस सर।
बट इसमें कॉन्सेप्ट सारे डिस्कस किया गया है।
यस सर।
ठीक है। और कोई और क्वेश्चंस नहीं है तो अच्छा कैसा? हाँ
एग्जाम कितने मार्क्स का है?
वो तो मुझे पता नहीं है, अभी तो कोर्स शुरू हुआ है।
75 सर।
ऑब्जेक्टिव?
हाँ ऑब्जेक्टिव ही होगा, एमसीक्यू होगा। ठीक है चलो, और तो कुछ डाउट तो नहीं है तो ये सेशन अच्छा कैसा लगा ये सेशन? ठीक था?
बहुत बढ़िया सर।
अच्छा चलो, अगले सैटरडे फिर से मुलाकात होगा। वी विश यू ऑल अ गुड वीकेंड। बाय।
थैंक्स सर। बाय।
ओके, यू मे लीव नाउ।